The graph below is the function f of x. F of x has an infinite discontinuity at x equals what? So an infinite discontinuity is the same thing as a vertical asymptote. I should specify that it would be vertical asymptote. All right, and if you'll notice here at 3, that's where that would exist, because on one side the limit's going to negative infinity, and the other side the limit's going to positive infinity. We just need either one of those left or right hand limits going to positive or negative infinity, and then that makes it an infinite discontinuity. So at x equals 3, that's happening. F of x has a jump discontinuity at x equals what? So a jump discontinuity is where we move from one y value to another with a big gap in between. So looking over here at 7. At 7, what's happening is the limit from the left is something less than 1. The limit from the right looks like it's 2. That does not agree with one another. Since those two are finite and not equal, that's a jump discontinuity. So there's a big gap there. That's where the jump name comes from. F of x has a removable discontinuity at x equals what? So a removable discontinuity is a place where it is discontinuous, but the limit exists. So the limit does not exist if we have an infinite discontinuity. The limit does not exist if we have a jump, but it does exist if we have a hole in the graph, because the limit from the left and the limit from the right agree with one another. So at -7, we have a hole, and that is a removable discontinuity.